I'm now going to very briefly touch on words and context approaches to text analysis. There's a quote by Firth that reads, "We know a word by the company it keeps," which is to say that we understand the meaning of words by the words that surround it. And this is much different from the bag of words approach, of course, which makes the unrealistic assumption that context does not matter. But at the same time, these approaches that account for the fact that words matter in context, they're much more complex, right? Both technically and computationally, they can take quite a long time to fit. And they were introduced very recently, really only in the last decade. Some examples include LSTM models or long short-term memory models. There are models that estimate word embeddings, which are really cool for understanding the meaning of words relative to other words. And they use a type of neural network. And there's a working paper on this in Political Science by Sperling and Rodriguez. So I'm not going to go into any technical detail here. I just really want to say something about the benefit of taking words in their context versus bag of words approaches. So this figure is from the Chang and Masterson article. Chang and Masterson have a recent article in the journal Political Analysis that looks at LSTM models. You don't need to know what LSTM models are other than the fact that they take words in their context into account. And they compare them to a number of what are essentially bag of words approaches. So this SVM model in the second row, support vector machines, is a bag of words approach, as are the others. And what they do is they task themselves with trying to classify whether a social media post on Weibo, which is the Chinese Twitter, whether a post is about politics or whether it's about something else, like about celebrities or food or sports or something like that. And so they use these different types of models, a bunch of bag of words approaches and one word in context approach style model, this LSTM model. And they make predictions using this. I'm not going to talk about how they do it. I really just want to make a general point here. And then they look at how accurate these models are. And they find that the LSTM model, the one that takes words in context into account, performs best. So the accuracy of predicting whether a post is about politics or whether it's not about politics is around 91%. And the second best performing model is around 88%. So the worst you can do in this case, because it's a balanced data set, and a balanced data set means that there are equal numbers of zeros and ones, or there are 50% that are non-political and 50% that are political. So the best you could do, or the worst you can do, is a coin flip. All right, so if I just flipped a coin for every single post, my accuracy will be 50%. But with these models, right, the models that are on this figure right here, we're achieving an accuracy, at least in the best model, of around 91%, and the second best model around 88%. And to me, this is actually a really, really small difference. Does taking words in context improve accuracy? Yes. But the benefits are actually quite marginal. And I think you need to take this into account versus the cost of, one, learning these models, and two, applying them and fitting them, because it can actually be quite time consuming to fit these kinds of models. And this is just a table showing something similar using precision and recall. And I'm going to abuse terminology here, but precision and recall are essentially a different type of measure of accuracy. That's not quite correct, but you can think of it as that, at least for the time being. And we can see that the differences between the model at the top on the first row and the second row, the one that takes words into a context into account, and the one that takes a bag of words approach, is actually minimal. So it does perform a little bit better, but not all that much so. And I think there's actually a gap in the political science literature looking at whether the model we use for classification tasks like this actually ends up mattering for the results we actually get for our substantive question of interest. So just to sum up the past three lectures, there is an approach that just looks at keyword frequencies, right? This is simple in principle, relatively simple in practice. but it can be challenging to the extent that determining what keywords to use is difficult. So when we looked at the King et al. Article regarding the Obamacare and Boston bombing tweets, we saw that there is pretty wide variation in the keywords that people come up with when trying to search for certain topics, and that these differences, this variation, has relatively large effects on potential results. Then there are bag of words approaches, which is based on a false assumption that the context of words does not matter, but at the same time they can be extremely useful in practice, which we'll see in a few weeks' time. At the same time, there are meaningful choices to be made with respect to pre-processing the data. So as I mentioned in the second lecture, there are about 7 steps that you need to, or you have a choice about which to make, and they can have effects on your final results. And then lastly, there are models or approaches that take the words in context into account. Most of the models that use these approaches are cutting edge, right? They're very recent. At the same time, they're technically and computationally expensive. And so although they may perform best, we need to weigh that against the benefits, which might actually be marginal. So my advice, or my suggestion at least, is to not fixate on the technical performance of these kinds of models, right? They can be actually very, very cool, but for substantive application, you should think about whether the benefit that they might provide is actually worth the cost of time and for you to code and learn these types of models. But I will talk about them, I suspect, at the very end of this course.